All right, in this video we're going to be talking about how you can predict the way that the graph of a function will be modified by looking at the way that the equation of the function has been modified. You can see here the textbook pages and objectives that are covered. So here we have a nice simple function, a linear function, f of x is equal to 2x plus 3. Okay, we know already that this thing is called a function. We also know that this side in function notation, that does two things. One is it acts like a name, and two, it tells me what to plug into my function. The other side explains the way that this particular relation or this particular function works. Whatever I plug into this function, that number will be doubled, and then I'll add 3 to the product. And that's how I determine my output. Okay? We can think of this as being the function itself, and it makes sense if we think of function notation as being a name, because this is saying to me that the name f is, equals means is, this particular function over here. So all that makes sense based on what we've learned so far, that we can think of the 2x plus 3 as being the function. Okay, so with that in mind, we're going to talk about something called the argument. The argument of a function is what the function is operating on. Okay, the thing on which the function operates. And how do I know what the function is going to operate on? Well, it's whatever I plug into the function. And so in this case, my argument is represented by the letter x. So we know that the way function notation works is that whatever's in the parentheses is what I'm going to plug in. So consider this, f of 2 is equal to 2 something plus 3. The way function notation works is I know that the number that's here is what gets plugged in for x. So in this particular case, the argument of the function is going to be 2. The thing that the function is operating on is 2. In the original function notation back here, the argument is considered x. So we can see that the argument could be a variable, it could be the number. And as we go through this chapter, we'll see it can be a whole variety of other things. In fact, we'll come to a time where the argument of a function might even be a different function. But for right now, the main thing for you to recognize is that when we talk about argument, we're talking about the thing that is being plugged into the function. So consider this. If I want to take this function and modify it by adding something to the argument, maybe I'm going to add 2 to the argument. What does that mean? Well, what I would do is take the function, I haven't changed its name, it's still function f, but I'm going to add 2 to the function's argument. So the argument currently is x, and then I'm going to make it 2 larger, x plus 2. So when I say add 2 to the function's argument, this is literally what it means. Now, how does that play out when I look at the equation? Well, we know the way function notation works, the equation stays the same over here, except whatever is in the parentheses here gets plugged in for the x that was over here. So in this case, if I modify my argument by increasing its value by 2, the result is over here, I get an x plus 2 in my parentheses where the x used to be. And of course, then I could simplify that if I wanted to. In this case, the way I would simplify is by distributing this 2 through the parentheses. That would give me a 2x plus 4. And then I could combine my like terms to end up with a 2x plus 7. So when we talk about modifying the argument, this is what we mean. Now let's contrast that with modifying the function itself. Suppose I say I want to add a constant to the actual function. In other words, I'm going to add, let's say 2 again to the function. Well, what does that mean? That means take my function, and I'm not changing the argument now, I'm actually adding 2 to the function. So that would look like my function plus 2. That's what that would mean. Take function f and add 2 to it. Now what would that look like? Well, if I'm adding 2 to one side of the equation, we know from algebra that that means I have to add 2 to the other side of the equation. And so there's my original function, and I'm adding 2 to it. So what we find is that f of x plus 2 would be equal to, all I need to do here is combine my like terms, 2x plus 5. Okay? So this is the difference between working with the function and working with the function's argument. In the following video and in the worksheet that you'll be doing for your homework tonight, we refer to those two things frequently and often, so you want to make sure you're very comfortable with the difference between the function itself and the function's argument.